Thank you so much, Jake. Thank you so much for all of you to be here today. For me, it's a pleasure to be here discussing the use of hydrogen internal combustion engines and fuel cells as decarbonization pathways for the long-haul sector. So I think it's a very nice lineup today, since we discussed a bit of the calibration side of fuel cells. Those aspects were included in this presentation for the fuel cell level. We just heard about like the fuel cell stack and the balance of plant importance in order to be able to capture all of these temperature, relative humidity, and driving profiles in the balance of plant. And this is also included in this presentation. But overall, the goal of this is looking into the technical economic sides of fuel cell and hydrogen ice once we apply those powertrain options for the long-haul sector. So basically, the presentation today will be talking about on the carbon neutral goals and overall transport outlook for the long-haul sector, followed by the total cost of ownership. That's a very important parameter to be accounted for the heavy-duty sector, and finally, results and takeaways. So there's a strong movement towards decarbonization in the energy sector that was initiated back in 2016 with the signature of the Paris Agreement, and several were the countries that have committed to the carbon neutrality goals in 2050-2070 timeframe, and that, of course, has been scaled down, cascading down to the transportation sector, since the transportation sector represents 23% of all CO2 emissions from the energy sector. So, in terms of the heavy-duty sector, several of the regulations that are in place today in order to support this transition and require specific CO2 reductions. And you have, for example, CARB in the US requiring more than 40% Class 7 and Class 8 tractors to be zero-emission vehicles by 2030, and also in Europe, 45% CO2 reduction for the heavy-duty sector. So those are quite interesting targets to be met in those time frames. So several technologies can support